All right, everyone get ready because today we're going deep, deep inside, and I mean really deep inside, into one of the most amazing systems in your body, the immune system. We're talking about such a complex force. It's so efficient, and it's working all the time, fighting off invaders you didn't even know were there. And if you know me at all, you know I love visuals. Luckily, the source we're using today totally gets that. They break down this whole complicated system with this brilliant analogy. They compare the immune system to an army. And I mean, when you think about it, different units with their own jobs, specialized roles, constant vigilance, it really is a war zone in there. The source points out that your immune system has 12 different jobs that it's doing at any time. And to get all of that done, it has to use 21 different types of cells and 2 different protein forces.
Yeah.
It's a level of organization that would impress a 5-star general.
And it's really interesting how that army analogy is more than just a simple comparison. Your skin, for instance, is like a wall protecting a giant empire.
Mm.
It's your first line of defense.
So imagine this. You're gardening, and bam! You get a little cut from a rusty old trowel. No big deal, right? Wrong. Bacteria see that tiny little opening as an invasion route. It's like the beaches of Normandy.
Yeah, and that's where the scale of this battle gets really crazy. A tiny little cut like that can quickly become home to billions and billions of bacteria, doubling their numbers every 20 minutes.
Wow, that's some crazy exponential growth. So how do we not just become a walking petri dish?
That's where the macrophages come in. Your frontline soldiers, they're everywhere in your body,
Yeah.
just patrolling, ready to gobble up anything that looks out of place.
You think you know how many bacteria a single macrophage can take down?
Oh, I think I can take a guess at that one. It's pretty impressive. A single macrophage can eat 100 bacteria.
100. That's
Yeah.
a whole battalion. But it's not just about eating, right? They're doing something more strategic, aren't they?
Yeah, exactly. Macrophages are way more than just brute force. They're brilliant tacticians. By eating all that bacteria, they trigger inflammation. It's like calling in reinforcements and getting all the defenses ready.
So that swelling and redness that you see around a cut, that's not just the injury, it's the macrophages getting ready for battle. Pretty clever.
Exactly. But sometimes your enemy just doesn't give up. And even those brave macrophages need help. And that's when the neutrophils, the heavy artillery, come in.
The neutrophils, the source calls them kamikaze pilots, which sounds intense.
They really are incredible, super aggressive. They just launch themselves into the fight, releasing powerful chemicals, destroying everything. And you're right, they do have a self-sacrificing part of their strategy. After about 5 days, they basically self-destruct so they don't damage the surrounding tissue.
Wait, so they have a time limit? That seems counterintuitive. Why wouldn't they just keep fighting?
Well, think of it this way. Neutrophils are super powerful, but their weapons aren't very precise. They could end up hurting your own body if they stayed around too long.
So it's like a safety switch to make sure they don't go rogue. Checks and balances.
Exactly. And that brings us to another really important part of all of this, the dendritic cells, the intelligence officers of your immune system, gathering info on the enemy and making sure the response is super precise.
The source actually calls dendritic cells the brain. And I can see why. They're not just fighting, they're analyzing the enemy and making the best plan of attack.
Yeah, that's a great way of putting it. They're constantly on patrol, collecting samples of the invaders, breaking them down, and then they present these little pieces on their surface. It's like they're holding up a wanted poster for the rest of the immune system.
So they're saying, hey everyone, here's the bad guy, let's get him.
Yeah, exactly. And where do they take this wanted poster? The lymph nodes, the headquarters of your immune system. There are billions of T cells there, highly trained specialists, just waiting for orders.
So I'm picturing this giant training area where T cells are doing obstacle courses and learning combat skills.
It's not too far off. The source says that T cells go through super hard training. Only about 25% make it. Only the best of the best survive.
That's an elite force. So what happens to the T cells that pass the test? They're ready for action, right?
Absolutely. Each T cell has this unique receptor that's designed to recognize a specific enemy antigen. It's like a lock and a key. Only the right T cell can unlock the defenses against a specific invader.
So the dendritic cell, with its wanted poster, it's looking for the T cell with the right key, the one that can target that specific threat. Molecular matchmaking.
Exactly. And when that match is made, that's when things get really exciting.
Okay, I'm ready. What happens next?
That T cell, now that it's activated, it starts to rapidly multiply, creating an army of clones, each one of them ready to take down that specific enemy. It's like a chain reaction, it's just this giant ripple effect, and the immune response just explodes. And this is where it gets even cooler with T cells.
Lay it on me. The source mentioned different types of T cells, but I'm still a little fuzzy on what they all do.
Okay, so Yeah, not all T cells are the same. Some become what we call effector T cells. These are the frontline soldiers, the ones who go right at the enemy. They release these toxic chemicals. And they could even punch holes right through infected cells, just wreaking havoc.
So they're the hand-to-hand combat specialists.
Right. But then we have another group, the helper T cells. These guys are like the masterminds, the strategists.
So less about fighting and more about coordinating.
Yeah, that's it. They don't kill the invaders directly, but they're super important for activating other immune cells, like B cells, which we'll talk about in a sec.
It's amazing how all of this works together like a perfectly choreographed dance of destruction. But you mentioned memory cells earlier. What's their deal?
Oh, yeah. The memory cells, they're the key to long-lasting immunity. Some of those T cells that were activated, they become memory cells. And they stick around long after the fight is over, ready to jump back into action if that same enemy ever comes back.
So they've learned from the experience. Like they've got a mugshot and they're ready to sound the alarm before the invaders can even get comfortable.
Yeah, it's this incredible system. Adaptive immunity. Always learning. Always evolving. Protecting you from future threats.
It's like, how did the system even come about? It's so intricate, so well designed.
It's a true marvel of nature. But we can't forget about the other major players here. The B cells. Remember those wanted posters the dendritic cells were carrying around? Well, those aren't just for T cells.
The B cells, they're like the weapons factories,
Yeah,
churning out tons of antibodies targeting those specific enemies.
that's it. B cells are fascinating. They can produce this insane variety of antibodies. Each one is custom designed to bind to a particular antigen. Like they have this massive arsenal ready for anything.
It's that lock and key thing again. The antibody has to fit the antigen perfectly.
Exactly. And when that match happens, the antibody grabs onto the invader, marking it for destruction.
So the antibodies aren't doing the killing themselves. It's more like they're tagging the invaders and letting other cells do the dirty work.
Yeah, think of it that way. They can neutralize toxins, block viruses. They can even trigger this system called the complement system. It's this cascade of proteins that can basically make bacteria explode.
Talk about going out with a bang. So antibodies are more like these multi-tools.
Exactly. And this is where our helper T cells come back in. They're crucial for getting those B cells going and making sure they're making the right antibodies.
So the helper T cells are like the conductors.
A beautiful analogy.
Yeah.
But don't forget, this is a war zone. And the enemy is relentless.
Mhm.
While all of this is happening, the battle is still raging at the site of the infection. Macrophages and neutrophils are still fighting. But they're usually outnumbered.
It sounds pretty intense down there, like some microscopic action movie.
It's pretty wild. But this is where those antibodies arrive. And they can completely turn things around. The invaders are suddenly tagged, helpless, and totally vulnerable.
It's like the cavalry coming over the hill. So what happens to all those invaders after the antibodies get them?
But remember the macrophages, they love anything these coated in antibodies. It's like they've been sprinkled with cheese.
Okay, now that's an image. So they're cleaning up the mess, restoring order.
That's it. And all of this, the attack, the antibodies, the cleanup, it all happens so efficiently. It's all thanks to this constant communication between the cells.
It's crazy when you think about it. This whole battle, this microscopic war is happening inside us all the time, and we don't even know it.
Yeah, it's a testament to how powerful and amazing your immune system is. It's evolved for millions of years to protect you from this world full of threats.
It's like our bodies are having these epic battles, and we just have no idea. But now that we know about it, I don't know, I just feel kind of amazed by it all. This incredible system working so hard to keep us healthy.
I know what you mean. And the source really hits on that, talking about the endless wonder and the beauty of it all. When you start to see how intricate life really is.
It's true. But I gotta be honest, I'm still kind of fuzzy on some things. Like the source mentioned that some antibodies have different jobs. Can you break that down for me a little?
Oh, yeah, sure. It's not like antibodies are just a one-size-fits-all kind of thing. They're actually a whole bunch of different proteins, each one with its own special job to do.
So it's not just tagging invaders. There's more to it than that.
Way more. Think of it like this. You wouldn't use a hammer to fix a leaky faucet.
Right.
What?
You need the right tool.
Exactly. Same with antibodies.
Okay, so what are some of these special antibody tools?
Well, there's IgM. It's kind of like the first responder antibody. It's the first one on the scene when there's an infection. And it's really good at activating the complement system. It's like this chain reaction of proteins.
Yeah.
And they can basically blow holes in bacteria and destroy them.
So IgM is like the demolition crew.
Pretty much. Then there's IgG. This one's all over your bloodstream. It's like a real multitasker. It can neutralize toxins, make it easier for macrophages to eat the bad guys, and it can even pass through the placenta to help protect babies.
Wow, so IgG is like the superhero of antibodies.
I like that. And then there's IgA. This one's hanging out in things like saliva, tears, even breast milk. It's all about protecting those delicate areas, like your respiratory system, your digestive system, all those places that are in contact with the outside world.
So it's like the border patrol.
You got it. Now, IgE, this one's a little different. It's kind of the one that gets blamed for allergies.
Oh, so it's the one that causes all the sneezing and itching.
That's the one. But it does have a good side to it. It's good at fighting off parasites. And lastly, there's IgD. This one's a bit of a mystery, to be honest. We know it's on the surface of B cells, but we're still not sure exactly what it does.
So IgD is the one we still need to figure out.
Exactly. It just shows you there's always more to learn.
Okay, so this has been mind-blowing, but it makes me think. Knowing how complicated all this is there anything we can do to help it out?
That's a great question, and one that scientists are really looking into.
So it's not just about luck.
It's not just about luck, no.
Yeah.
Think of it this way. Your immune system is like a garden. If you don't take care of it, it gets overgrown with weeds. But if you give it what it needs, it flourishes.
So how do we take care of our immune system garden?
Well, the basics are important. Getting enough sleep, managing your stress, eating lots of fruits and vegetables, all of that helps your immune system work better.
So all that stuff we already know is good for us.
Yeah, basically. There's no quick fix. But by taking care of yourself, you're giving your immune system the best chance to thrive.
This has been such an incredible journey. I feel like I've learned so much. I've got a whole new respect for this system. It's working so hard to keep us healthy.
It really is amazing.
Well, I think that about wraps up our deep dive into the immune system.
It's been a pleasure talking about all this with you.
Thanks for joining us on the deep dive. We hope you learned something new today, and maybe you'll even be a little more appreciative of your own amazing immune system. Until next time, stay curious and stay healthy.